Okay, just imagine for a second a world where distance just doesn't matter anymore. Think about crossing a whole continent, not in hours, but in minutes. Now, I know what you're thinking. That sounds like science fiction, but here's the thing. It's not. Right now, there's one country that isn't just drawing up blueprints to this future, they are physically building it. And honestly, it looks like they're rewriting the laws of physics as they go. So let's just jump right in with a question that sounds, well, kind of impossible. We all get how you break the sound barrier up in the sky. You need jet engines, sleek wings, just a ridiculous amount of power. But how in the world do you pull that off when you're still attached to the ground? How do you fly without ever really leaving the Earth? Well, here's your first big clue. 700 kilometers per hour. And just to put that into perspective for you, that's actually faster than the cruising speed of a lot of commercial jets. And this speed was just hit by a 1-ton maglev test vehicle in China, a machine on the ground that can literally outrun an airplane. But the speed? That's only half the story. The really wild number here is the acceleration. They hit that speed not over a few minutes on some long track, but in 2 seconds. Yeah, 2. In the time it just took you to blink, this thing went from a complete standstill to a total blur that would make a supercar look like it was standing still. This isn't just some test, it's a world record for superconducting maglev. Just look at this headline for a moment from South China Morning Post. This is the news behind today's video. Flying blind at Mach 1, how China is bringing world's first supersonic rail to life. Peer-reviewed paper sheds light on Chinese research team's sonic breakthrough, achieved by listening to system's power supply. With that said, let's go straight to the intro. So you've got to be asking, how are they actually doing this? Well, China has pretty much mastered 3 different ways to get magnetic levitation to work. You've got your standard electromagnetic, you've got permanent magnet, and then you've got the holy grail, superconducting levitation. That's the one that gets you these insane record-breaking speeds. By cooling the magnets down to almost absolute zero, they create magnetic fields so powerful that they can launch a train with practically zero friction. But, and this is a huge but, all that incredible speed is completely worthless if you can't control it, right? I mean, as you start pushing the sound barrier on the ground, the physics just get brutal. You get these insane shockwaves, crazy vibrations, and they literally just tear conventional sensors to shreds. Your radar's useless, optical sensors can't see a thing, so you're basically piloting this massive thing at Mach 1 totally blindfolded. So how do you solve a problem that seems impossible, like flying blind? Well, this is where things get really, really clever. Scientists over at China's Institute of Electrical Engineering came up with what you could almost call a ghost in the machine, a way to see without having any eyes. The official name for it is sensorless speed estimation. And it's brilliant. Instead of bolting on all this fragile hardware that's just going to get ripped apart by the sheer forces, they developed a system that uses the motor itself as its own sensor. It is such an elegant and tough solution, and it just completely sidesteps the physical problem of supersonic travel. So how does it work? Well, it's pretty much a 3-step dance, kind of like listening for a heartbeat. First, the system shoots these powerful electrical pulses into the coils all along the track. Then, and this is the genius part, it just listens. It listens for the tiny electrical echo that bounces back. And finally, a super smart algorithm crunches the data from those heartbeats in real time to figure out the train's exact speed and position. And the results from this method, they are just staggering. I mean, look at this. They tested this at over 1,300 kilometers an hour. That's well past Mach 1. And the speed tracking error was just a little over 1%, which is amazing, but get this, the positional accuracy was 4 millimeters. 4! It knows its exact location down to the width of a couple grains of sand while it's moving faster than a bullet. That's not just good engineering, that is pure absolute dominance. Now you have to understand, this isn't just about setting records in some lab somewhere. China is, without a doubt, the king of actually making this tech work in the real world. They've already got 5 maglev lines running every single day, including the world-famous Shanghai maglev. And what's next? It's straight up science fiction. Vacuum tube maglev. The idea is to get rid of air resistance completely, and they're aiming for commercial travel speeds over 1,000 kilometers an hour. And what does a future like that actually feel like? Well, this chart really puts it into perspective. That 700-kilometer trip that takes a normal train 11 hours today? Yeah, that could be done in just 35 minutes. The 4-hour ride from Beijing to Shanghai cut down to just 90 minutes. We're not just talking about making travel a little faster. This tech is literally shrinking the planet. Okay, but what if this wasn't just about trains? This mastery of electromagnetism we're seeing, it's now popping up everywhere. I'm talking from the decks of aircraft carriers on the high seas, all the way to the very edge of space. This isn't just one project, it's a revolution on all fronts. So say hello to the Fujian. This is China's newest, baddest, most advanced aircraft carrier. And what's the big deal? Well, it makes China only the second country on Earth, right after the US, to field an electromagnetic aircraft launch system. You know it as EMALS. So why is EMALS such a game changer? See, the old way of doing things involved steam catapults. Basically a giant, brutal piston that just slams a jet into the air. It's violent, it's inefficient, and it really beats up the planes over time. EMALS, though, it's like a surgical tool. It's a linear motor that gives you this smooth, powerful, and precise acceleration. And get this, China developed its system using a more stable and efficient DC power system, arguably building a better mousetrap right from day one. But when you have this level of ambition, it doesn't just stop at the coastline. Because if you can use this incredible force to fling a fighter jet off a ship, what else could you launch? And this is the grand vision. A space catapult. The whole idea is to use these same super powerful magnetic rails to shoot a spacecraft up to hypersonic speeds before the rocket engines even turn on. By giving it that massive initial kick from the ground, you can slash the amount of fuel a rocket has to carry, which drastically cuts the cost of getting into orbit. It could literally make China the gatekeeper to the solar system. So let's step back and connect all these dots. We've talked about Mach 1 trains, these crazy sensorless algorithms, electromagnetic aircraft carriers, even space catapults. What you need to realize is that these aren't just a bunch of separate cool projects. No, this is the dawn of an electromagnetic age, and it's all being driven by the same fundamental force. So what is the bedrock of this dominance? It really boils down to three things. First, a national vision that is laser-focused on turning wild research into real-world industrial power faster than anyone else. Second, a deep mastery of the core software, like algorithms that constantly tune the motors for peak performance. And third, using AI and neural networks to predict and perfect how everything works before you even build it. And that really just says it all, doesn't it? As one source put it so well, they aren't just dreaming about the future, they are building it, piece by metallic piece. This is all about a relentless, systematic drive to turn these huge ideas into concrete steel and powerful magnetic fields on a scale we've just never seen before. And that leaves us with one final, very big question. You know, electromagnetism is one of the four fundamental forces that holds the entire universe together. So what happens? What are the ripple effects across the globe when one nation starts to achieve this level of mastery over it, and then applies it to everything from transport and defense to space itself? Look, if you found this dive into the electromagnetic age as mind-blowing as I did, do us a huge favor and hit that like button. And hey, if you want to make sure you catch our next deep dive into the tech that's changing everything, be sure to subscribe. And of course, we want to hear what you think. Out of all this crazy stuff we've talked about, which one blows your mind more? Is it the planet-shrinking Mach 1 trains, or is it the solar system unlocking space catapults? Drop your thoughts in the comments below. Thanks for hanging out with us for this explainer. Until next time, keep looking toward the horizon.